Okay, let's take a look at the first section, first half of 22A. We're going to do the first 6 objectives here. Talking about lines here for 22A. So a lot of stuff you guys have seen before, talking about slope, point slope, some of the different equations. So first off, we're going to do the slope of a line. And this stuff you guys have seen before, rise over run. So what's the steepness of our line? Okay, and we do have this formula for slope, y2 minus y1 over x2 minus x1, as long as we don't have 0 in the denominator. And again, rise over run, change in y over change in x, delta y, delta x, delta means change. Any of these can be used to figure out the slope of a line. All right, and if we are vertical, we're going to be undefined, because then we'd be dividing by 0, and that's not allowed. So any 2 points can be used to find the slope. Doesn't matter where you pick your points, they'll all work. And you can reverse the order. If I say y2 minus y1, it's perfectly fine to say y1 minus y2, as long as we switch it to x1 minus x2 in the denominator. All right, so let's go ahead and do an example. We're going to do the 2 y numbers minus each other. 4 minus negative 3 all over negative 1 minus 2. So we've got 7 over negative 1 minus 2 is negative 3. So negative 7/3 would be our answer. And just a quick point, negative 7/3 is the same as if you have just a single negative, either in the denominator or the numerator. So we'll pull it out front. Okay? All right, so go ahead and take a look at problems 11 and 17. See how you do there. Okay, so one thing, we know that if we have a rise of 1 over 1, we should have a 45-degree angle of a line. But on our screens, if we have the same y mins and max, the same y scale as we do for the y scale as we do for the x scale, it's not going to look like a 45-degree angle because our screens aren't square on our graphing calculators. So our screens have a ratio of 3:2. So we want to, if we want to see this as we would see on a piece of graph paper, have our x values be 1.5, 3 over 2, times as big as our y mins and maxes. So a good one to use is 6:4, or we could use 30:20. We could use 15:10. That would actually be really nice if you used negative 10 and 10 like we normally do. But then stretch your x's to negative 15 and 15. Then you'll see the actual true slope as you would see it on a piece of graph paper, because now the tick marks are evenly spaced. And here, they're not. This scale of 1 is a little longer than this scale of 1. So now you can see, here's some various ones. I'm not going to go through this too much other than to say, if you have a negative slope, it's going down. And if you have a positive slope, it's going to be going up. Here's some positive slopes versus some negative slopes. And the more positive or negative, the steeper it's going to be. If your slope is 0, you're horizontal. If you're vertical, you don't have a slope, it's undefined. All right, so given a point and a slope, can we figure out what our equations are? Before that, let's draw a graph that contains the point 1, 4, 1, 4, and has a slope of 1 over 2. Remember, this is rise over run. So we're going to go up 1, and we're going to go right 2. Up 1 over 2, and now we'll have a slope like that. This point was 1, 4. This point here, we went up by 1, so now our y value is 5. We ran 2, our x value is 3. Could do the same thing here, 1, 4 to start. We're going to go down 3, 1, 2, 3, and we'll go over 4, 5. And we'll have a negative slope, a downward facing line. So with that, try problem 23. Okay, let's take the equation of a vertical line. That's going to be x equals a number. If we were to graph this, we'll find x is negative 2. It doesn't matter what the y value is. It could be any y value, so if we connected them, we would have a vertical line. So here's your equation. If it's x equals a, it'll be a vertical line where a is the x-intercept. That's the point where you'll go through on the x-axis. Okay? Now, let me skip ahead real quick. I want to make sure we see that for the horizontal lines as well. Y equals b. If we have a line like this, we're going to be horizontal. So x equals a, your vertical. Y equals b, your horizontal. Okay, let's see. How far did I skip ahead? There we go. Use point slope, form of a line, and identify horizontal lines. So we have this equation here. This is point slope. Y minus y1 equals mx minus x1. If we know the slope is -3, m is our letter for slope. We've got an x value and a y value. Let's plug it in. Y minus my y value equals m, x minus my x value, plus 1. So y minus 4 equals -3. X plus 1 would be in point slope form, and that's perfectly fine to leave it like that. If we were going, this is point slope. We could also go into slope intercept. Which is y equals mx plus b. And so that's going to be get y by itself. So -3x minus 3. Move the 4 over, y equals -3x plus 1. These are the exact same lines, just in different forms. All right, what about the horizontal line containing this point, -4, -1? Don't need to graph it, but if we did, it would look like this. And if we're horizontal, we're going this way. Okay, so we talked about that just a second ago. This is going to be horizontal. Y equals -1 would be the equation for our horizontal line. Okay, how about if we have 2 points? Can we find the equation here? First thing we're going to do is find the slope. So let's go back in and figure out slope. Y minus y1 minus a negative over x1 minus x2. So we've got 5 over -4. So -5/4. And then we can pick either of the lines we like. It doesn't matter. So we're going to say y minus a y number equals m x minus the x number. So x plus 1 minus a -1. And if I picked 4, I got to pick the 1, the -1, sorry, here. I could have very easily picked -1 for the y number, but then I would have picked 3 for the x. All right, so that is an equation. We can leave it just like that. No problem there. If I said give me slope intercept, we would move this around. Y minus 4 equals -5/4 x minus 5/4. And we're going to add 4, which is the same thing as adding 16/4. So y equals -5/4 x plus 11/4. Those two equations are both the same, it just depends on what form is asked for. Sorry, try 37. Okay, last objective here for today. Write the equation of a line in slope-intercept form. We've already talked about this. Here it is again, y equals mx plus b. M's your slope, b is your y-intercept. So, we'll see here, all of these have a y-intercept of 2, and varying slopes from horizontal, 0x up here, okay, up to 3 or -3x, the steeper, these ones here, going up and down. Alright, so graph the following lines on the same square screen. Let me pause this for a second. I don't think I have my graphing calculator up. Okay, let's try this. So if we have a variety of equations, we can do them on different y's. So 2x, 2x plus 1. Just going to write them on separate lines. 2x minus 1, 2x plus 4, and 2x minus 4. And I want to make sure my window is a nice 3:2 ratio, so I'm going to make it -15 to 15 for my x values, leave my y values at 10. always have my x values 1.5 times the y values when we graph it. And there we go. Here they come. They're all going through the number 1. Well, that's not true. What the heck happened here? Oh, no, sorry. They're not all going through the number 1. They're going through the number 0, 1, -1, 4, and -4. They all have a slope of 2. Sorry, I wasn't paying attention to what I was doing right there. I was thinking the slopes were changing. But it's the y-intercepts that are changing here. So we're going through 5 different points on the y-axis, and they're all parallel to each other. They all have the same slope. All right, go ahead and try problem 45. If you've got any questions, let me know in class. And that should do it. Good luck.